Hello everyone, my name is Tulika Lal and I'm a PGDM Business Design student at Wellinkar Institute of Management, Mumbai. And today I, along with my other team members, Neeti, Sakshi and Saini, are going to present a case on edge computing. So first, let's try to understand what exactly is edge computing. So imagine you are in a large library and you need to find a specific book. So if the library is organized with all the books at a centralized location, you might have to walk a long distance to find the book that you need. And this centralized location acts like a traditional cloud computing where all the data processing happens in big data centers, which are generally far away from where the data is needed. Now, imagine if the library had small bookshelves scattered throughout the building and each contains books most relevant to the people in that particular area. Now, anybody would be able to access the book very easily. This is the idea behind edge computing, wherein instead of sending all the data to a central location, the data is processed wherein the data is generated or needed. It is like small bookshelves, right where you need them. Let's take another example. Imagine that you're playing an online video game on your mobile phones. If the game's data has to travel all the way to a central server and then back, then imagine you may experience delays or lag, right? But with the help of edge computing, the game's data can be processed at a nearby location like a local server in your city. This reduces the distance the data has to travel, and the game that you're playing would be smoother and would respond more effectively. So the case that we are considering today, which is about ABC Communications, so even they are working on providing these local bookshelves or nearby servers for businesses and consumers, enabling faster and more efficient cloud computing experiences. Sorry, efficient computing experiences, whether it is for online gaming or industrial automation or other applications that require quick data processing. Moving forward to the next slide. So this is the Canavan framework, which we have used to analyze the ABC communication case, which is based on edge computing that I just now spoke about. So this framework offers an approach to understand and navigate complex and dynamic landscape of edge computing. And it is a system which is rapidly evolving and changing. So this framework helps to categorize different domains of this complex case, and the domains includes obvious, complicated, complex, chaotic, and disorder. And through this framework, we can understand how ABC communications can approach each aspect with a tailored strategy. For example, if we consider the obvious domain, we need to understand the global presence of ABC communication. So, as per the case, we got to know that it has 60 POPs, which means points of presence. Sorry. So, it has 60 POPs globally. So, the response would be to continue leveraging its strength in edge computing deployment. The second is integration with various infrastructure, wherein we need to have expert analysis. So the response would be to engage with experts to design and implement seamless integration strategies. The third is complex domain, wherein we need to navigate fragmented ecosystem, and we need to have a structured approach to this. So yeah, so the response would be to experiment and iterate to have a collaboration with third party developers. And here we need to understand the unsettled standards. The next domain is chaotic domain, wherein we need to understand the rapid evolution of edge computing. So there would be unpredictable changes that may happen in this sector. So the response would be to act quickly to respond to shifts so that we can monitor the landscape in a better way and be prepared in uh, case cases wherein we need to act more responsibly. The next is disorder domain, wherein the territory is uncharted. So we don't know in which domain this area would lie, and the response would be to investigate further and clarify uncertainties to apply appropriate strategies. Over to Sakshi. Thank you.
In this slide, we'll talk about the struggles in delivering responsiveness and agility. So, the increasing need to collect larger sets of data, especially for the MI and AI models, has created the requirement for lower latency rate and high network backhaul cost. And organizations are continuously struggling to deliver responsiveness and agility in implementation when dealing with the data processing and when they are dealing with analytics. Some of the used cases are in the of this of delivering responsiveness and agility are in the case of the healthcare industry, the retail and the e-commerce industry, and in the case of autonomous vehicles. In the case of healthcare industry, they continuously struggle to monitor real-time patients generated health data. In the case of retail and e-commerce, they look for real-time incentives and facial recognition. And in the case of autonomous vehicles, real-time avoidance and object avoidance and collision alerts.
Now, let's talk about the latency sensitivity. While deep diving the case, we come upon the concept of latency sensitivity. To understand this, we first need to understand what this term means. This term actually means real-time application. So this can be any applications where high or variable latency is going to affect negatively performance of the application. Just imagine you are driving an e-vehicle, that is an automotive vehicle. Suppose there is Tesla and the vehicle is not getting the live information. So what will happen? Even if there is a latency of microseconds, fatal accident can happen. This use case can also be used in identifying the healthcare or the industrial automation. For example, a machine is running and we need to identify the defect. If we don't have the real-time data, then all the industry 4.0, all the industry automations will go down. That's why our latency should be negligible or should be very less. And that's where the edge framework comes into place. Like my colleague Sulika explained in her part that we are providing the data source near to the system. So therefore, the fragmentation is so near that there is no latency or minimal latency. Now, deep diving, we have the opportunity areas. Now, the case discusses about ABC Communication. ABC Communication is a company that provides computer solutions which has an open door to multiple industries, including augmented reality, virtual reality, gaming, IoT, and autonomous vehicles. How they are actually providing the solution? What they are providing is an edge framework. With the help of this, they have partnership with IoT manufacturers, gaming companies, AR/VR developers, which expand the ecosystem and enable and the growth and provide a platform for innovations. Now, moving on, we have a great example of Singapore. What Singapore is trying to do is to create a smart nation. What is smart nation? They are initiating to connect all the hospitals, roadways, their industries, their healthcares, their working environment to a smart thing, which is connecting everything an edge framework so that we get the real time data. There is less latency, everything is connected. Similarly, we have an example of Siemens, which is leveraging this edge computing system in its manufacturing plants. What they are trying to do is they are going to increase 25% increase in their efficiency and opening new business opportunities worth rupees 100 million annually. So now over to Niti.
So coming to the application, microservices architecture and are constrained by latency and their performance. So first application is the financial trading platform. In this financial trading platform, uh, we use the microservices architecture in which the buying and the selling of the stock happens. So the fast response time is very much essential here. The delay can cost a lot of money. So they also provide customized, personalized investment advice based on how the stock market is doing and in which stock you should invest. The other application is the ad tech and the personalized marketing. In this, they use the small and the specialized services to show you that what is just right for you. In this, they just understand the customer behavior and what they are doing, where are you, what you like, and other things. In this, they make sure that the ads appear quickly, which is very much important. So this is also helps in the quick decision making of the consumer, also keeps the customer engaged for a longer period of time. The other application is the Netflix, which is a big player, but has a it also faces the latency issue here. So to enhance the user experience, it is adopting edge computing so that it can reduce the buffering by 40%, ensuring smooth streaming over a large subscribers and enhancing the real-time content delivery. One more application I would like to highlight, which is not mentioned in this case, is the healthcare telemedicine, which is very much important. In this, the real-time interaction between the doctor and the patient is very much important. So the low latency is required here for the video conference and data transmission and personalized health recommendation based on the patient data. So these applications highlight the critical need for microservices, architecture, and low latency, high performance edge computing to provide real-time responsiveness and personalization, enhancing user experience and meeting specific industry requirements. Moving towards the next is the actual benefits. Moving to the next slide is the actual benefits. And this, there are many benefits, but we have highlighted just a few one. This the first one is the improved user experience. In this, the response time is very much important to enjoy the application. For example, in online gaming, the reduced latency helps in quicker reaction, which enhance the user experience and also customer engagement. The cost saving in this, the lower network can be directly impacted as the company's bottom line. So this is for instance, business using edge computing may reduce data transfer cost by processing data locally instead of sending it to a central server. Enhance security in this, the data is closer to the customer or the source where it is processed, so the data where the security is much more higher. The energy efficiency in this, the smart let the example of the smart city, which Saini has mentioned. In this, the use of IoT and other, it helps to reduce the latency, which leads to more efficient use of resources and energy, leading to reduced environmental impact. So concluding with this, I would like to end the case. Thank you so much for your time.
Thank you.